Before we start using variables, I need to tell you a bit more about C's compilation model. In the previous demo, I showed how the compiler takes a source file and translates it into an executable. Well, that was a bit of smoke and mirrors, so to speak. The compiler doesn't actually produce an executable. Instead, it produces an object code file for each source file. This object code is an intermediate format that's language independent. A separate program called a linker takes the object files and links them together to form an executable. It also typically performs additional optimizations given its awareness of the different parts of the program. This is something the compiler may not be able to do given only the separate source files. The linker gathers the required object code to form a valid executable program on the target machine. The CL command from the Microsoft compiler simply provides a shortcut to optionally call the linker automatically. This happens by default, but you can tell it to just compile and not link using the /c switch. Let's give it a try. I'll start by creating a new source file called main.c for the program's main function. I'll then add the standard main function and return value. In the previous demo, the main function printed a message. This time I'm going to use a separate function, which I'll call hello. For that to make sense, I need to provide a suitable definition for the hello function. I can now save and compile and run, and this single source program should work just fine. Great. Now to illustrate the distinction between linkage and compilation, I'll copy the hello function definition and place it in a separate source file. Okay, now we can close that. Note that that isn't a valid C program by itself, but it is nonetheless a valid source file. Now back in the main source file, I only need to provide a function declaration, telling the compiler what the hello function looks like without revealing its implementation. I can now return to the command prompt to compile and link these together. Now if I attempt to compile these source files separately, the compiler will complain. In this case, the compiler complains that it cannot find the hello function's definition. Now how about the hello source file? In here, the compiler complains that it cannot find a suitable main function to act as the program's entry point. The solution is simple. First compile each source file and then link them together. I can tell the compiler to hold off linking using the /c or compile only switch. That works fine. Again, it's good. If we take a look at the folder, we can see the compiler produces one object file for each source file. Let's make it a little bit bigger. You see the two source files and the two object files. I can now link the object files together to form a valid executable. Now what is the executable's name? Well, the compiler picked a name from one of the source files. Let's see what it is. hello.exe. If you want to control this name, you can use the /fe switch. Now we can run the program. And sure enough, it works.